this was a question which was posted by Dipesh. Dipesh had asked, in a right triangle, if the area and perimeter are given, how can we find out all the sides of the right triangle? Dipesh, thank you for posting your question. This is how we solve these types of questions. So let's say that the area of the right triangle is given as, so area is given as, say, 6. And also let's assume that the perimeter is given as 12. And we are now asked to find out all the 3 sides of the right triangle. So let's imagine that a right triangle looks something like this. This doesn't look like a right triangle, but let's assume this is 90 degrees. So let's call this side as A for altitude, B for base, and I was about to write C, but let's call this side H for hypotenuse, right? Now, let's write the information that is already given to us. So area is 6. What is the area of a right triangle? Area is half AB, right? That is half altitude times base. And this area is given as 6. So from here we can say that then AB is equal to 12. We multiply both sides of the equation by 2. So we get AB equals 12. This is our first equation. Now perimeter is given as 12. What is perimeter? Perimeter is nothing but sum of the 3 sides. So what is given is A plus B plus H is equal to 12. This is our second equation. And now we know this is a right triangle, so we can apply Pythagoras theorem here. Pythagoras theorem simply states that hypotenuse square in a right triangle is equal to the sum of squares of the other 2 sides. So here they will be A square plus B square. So this is our third equation. So we have 3 equations, equation 1, 2 and 3, and we have 3 unknowns, A, B and H. So we have 3 equations, 3 variables. We should be able to find out the values of A, B and H. Also, for the purposes of this example, let's assume that A, B and H, they are integers. They are not fractions, or they don't have any decimal value, right? So how are we going to solve this question? So let's begin with the third equation. So let's scroll down a little bit over here, give ourselves a little bit of space. So let's say H square equals A square plus B square. Now what we are going to do is now we are going to add the term 2AB on both sides of this equation. So why are we doing this? Well, here you will clearly see this becomes A plus B whole square, right? But first, what is AB? AB is equal to 12 from equation 1. So 2AB will be 2 times 12 plus H square equals, now we can write this as A plus B whole square. So why did we want to write this as A plus B whole square? Because of equation number 2. From equation number 2, we have A plus B plus H is equal to 12, or we can say that A plus B is simply equal to 12 minus H. We just take the H on the other side of the equality sign, so we get this. Now we will replace A plus B by 12 minus H. So if we do that here, so this will be 24 plus H square equal to, now instead of A plus B we write 12 minus H, 12 minus H whole square. And see, now what we have here is we have an equation which has only one variable, and that is H. That is why we added the 2AB, so that we can write this side as A plus B whole square, and instead of A plus B, using the equation number 2, we have replaced A plus B by 12 minus H. And now we have this equation over here, which is equation in only one variable, which is H. So let's continue to solve it. So let's do it over here. So we have 24 plus H squared, let's just put some space here, equal to, now let's open this up. So this is A minus B whole square format, so which will be A square, which is 12 square is 144, minus 2AB, 2 times 12 is 24 times H, so this will be minus 24H plus B square, or in this case it is H square, or this will be, so H square and H square will cancel out, so we have 24 equals 1 144 minus 24h. So what we'll do, we'll get the minus 24 on this side, it will become plus, and we'll get this 24 over the other side. So here what we have is we have 24h is equal to 144 minus 24, or this will be 120, or simply here we will have h is equal to, let's give ourselves a little bit more space here, h will be equal to 120 divided by 24, which is simply 5. Do the division, we'll get 5. So now what we have is the hypotenuse, h is the hypotenuse, and hypotenuse is 5. Right? Now if we go back, we have AB is equal to 12, and we have A plus B equals, A plus B was 12 minus h, I believe, right? 12 minus h. So if h is 5, 12 minus 5 will be 12 minus h, or 12 minus 5, or 7. So let's scroll down again here. So we have AB is 12, AB is 12, but A plus B is 7. So now what we have is, we have basically, this is, let's assume this is A, multiply by B, then we get 12, but this A, when we add B, we should get 7. So how are we going to find out? So now we are dealing with these two equations, and we are trying to find out the value of A and B. Now, if this were a straightforward equation where we have the two variables, like something plus something equals something, or something minus something equals something, we can simply use the one of the two techniques. We know how to solve equations using simultaneous equations using method of substitution or method of elimination. But here we have the product and we have the A plus B. So what we will do, the way we solve these questions is that we are going to find out the factors of 12. So what are the factors of 12? The factors of 12, they are 1, 2, 3, 4, 6, and 12. Right? Now we have to take two of them such that when we multiply those two, we get 12. When we add them, we get 7. So if we take 1 and 12, so if we take 1 and 12, when we multiply, we get 12. But when we add them, we get 13, not 7. So I guess this combination then doesn't work. So 1 and 12, it does not work. This does not work. How about we take now 2 and 6. If we replace this with 2, and if we make this 6, we then get 2 times 6 is 12, but 2 plus 6 is 8, not 7. So 2 and 6 also, this does not work. What about 3 and 4? If we have 3 and 4, when we multiply, we get 12. When we add, we get 7. And yes, so 3 and 4, this actually works. So one of the values, A, can be 3, and let's give ourselves a little bit more space, and B can be 4. Now, this could be the other way around as well. We can say A is 4 and B is 3, it really doesn't matter. And we have already seen that H is 5. So going back to the three sides of our right triangle, so we had assumed this is A, this is B, and this is H. So we have seen that A is 3, B is 4, H is 5. So it doesn't matter which is 3, which is 4, but the three sides are 3, 4, and